I sort of included this slide here as what you get when you fail to exclude the things that I just listed for you on the previous slide. So we could call this the side effects or adverse reactions. It's sort of like taking a medicine that has adverse reactions of conventional physics and cosmologies. There are contradictions, dualities, paradoxes, uncertainties, magic, miracles, suspension of disbelief. Many questions are not allowed. Equation collapse, Planck limits, which is a magical mystery tour because those Planck limits are in fact just a combination of unexplained measurements. And so they too are in the unexplained category. As a matter of fact, to hit the ball out of the park, we might say if you're including unexplained measurements in your theory or model, basically your theory or model is just more unexplained stuff. Of course, we want to include successful ideas. We want to start with the best toe, theory of everything available in crafting a cosmological model. This is absolutely essential. Now, there's one thing about the wording here. Think about theory of everything. If you have a theory or toe, which in fact is correct and complete, there can only be one, mathematically speaking. In other words, there are not a number of different toes. There's only one possible. Because if a particular one, in fact, accounts for quote unquote everything, well, there's nothing left to do as far as making a toe is concerned. And so that what we have is what I call many imposter theories of everything. They claim to be theories of everything, but they're actually imposters. And if they use simple logic that I just presented to you, they would know that they're imposters. And so there's a certain amount of fraudulent activity there, in my opinion. Binary mechanics explores consequences of full quantization of energy, space, and time with complete equations for system state and its time development. Those are the equations which run the binary mechanics simulator where various studies were conducted, as well as the experiments of using data that other people gathered, such as my lunar laser ranging analysis and so forth, which I think are useful and potentially very successful approaches. Third, on our successful ideas list, assert conservation laws which postulated events in fact confirm, such as the conservation of energy. In the example of binary mechanics, none of the time development equations changes the number of one-state quanta. In other words, energy, which the one-state quanta represent, is conserved. Next, use unexplained measurements only after derived from first principles. In other words, there's nothing wrong with using any of these unexplained measurements, which other people call the fundamental constants, and which are listed in Appendix A in almost every physics textbook you can buy. But really, the title of Appendix A should be Unexplained Measurements. These are the greatest body of mysteries in physics and needs to be addressed before we can go on to further development of our knowledge of physics. Much as I said before, you need to master arithmetic before you can master algebra. You need to master algebra, at least the basics of it, before you can master calculus and go on to matrix algebra and so forth. Assert that physical principles are the same at microscopic and macroscopic scales. This is sort of the inverse of what I was saying in the previous slide. Include well-known and recently discovered phenomena. This is very important. Finally, the last item down below, a usable toe must be falsifiable. If binary mechanics or any other theory is to be used in crafting a cosmological model, there must be a way to falsify it. In the case of binary mechanics, it's rather easy. And I've tried to falsify it myself and failed every single time. And I've really put it to the test. Like I've talked about this crazy idea that due to the law of motion in binary mechanics, when we have full moon, the moon should be attracted to the Earth because the density of quanta between Earth and moon is greater during full moon as to when we only have a partial moon. And I was going to prove that this inescapable conclusion of binary mechanics is completely false, and I failed. It turned out the postulate or the prediction of binary mechanics was in fact true. The moon was closer to Earth by some 10,000 kilometers during full moon compared to about 10 days away from full moon, when from the perspective of the Earth, the moon is of course darker, and therefore there'd be less radiation and a lower temperature. Lower temperature means less quanta being emitted from the moon's surface to fill the space and increase the density of quanta between Earth and moon. Okay, just a quick summary of some of the major events in physics which have been won by binary mechanics as a theory of everything to use in making a cosmological model. First off, I've mentioned this already, I guess, is the century-long physics grand championship race, where we have the first ever derivation of basic constants from first principles. Every single one of the basic constants can derive without using any of them as an input variable anywhere. Bit function defeats the wave function. Okay, in 20th century antiquated quantum mechanics, they use the wave function, and the best they can do is get probabilities of events, not actual exact values. In this particular event is the best system state representation. We include in binary mechanics both position and momentum. The wave function only can do one of those at a time. So the bit function defeats the wave function 2-to-1. Best time development laws. In that competition, the bit operations, which are the analog in binary mechanics to the operators in 20th century obsolete quantum mechanics, the bit operations defeat both QED and QCD. That QED is quantum electrodynamics and quantum chromodynamics, which deals with proton structure. And I've thrown a little bit of mud at that one already in this talk, so we'll leave it there. Best methodological advance in particle physics is bit function analysis. Bit function analysis was used at 0 Kelvin. These equations were actually creating particles, 8 elementary particles, 4 matter particles, the 3 d quarks, which is down quarks, and the electron, and the corresponding 4 antimatter particles. And that was just an astounding result. Most parameters quantize. Well, space-time and energy quantization. Here we have a win there. There's no one who's attempting to quantize. Some people are taking little steps to say, well, let's quantize one of those 3 things and see how far we go. Binary mechanics just dives in and say, let's just see let's just do the whole thing in one blow. The weak force debacle. Actually, there was a Nobel Prize given for the so-called unification of the weak force. And to review for some of you who may not be familiar, that involves those crazy things that are called the W plus and minus bosons and the Z boson. This weak force debacle was exposed by providing the best physical force mathematical definitions. If you want to see those definitions, they're in the time development equations of binary mechanics and summarized in table 5 in the paper on my website of binary mechanics postulates. Finally, best prediction of hadron particle structure and energy states. I added this one to my list because recently I saw that there was a couple of people who were very sad that they still can't pin down what hadron particle structure is. The proton, of course, is an example of a hadron particle. And so I was saying, my God, we have these people that can't even read. This was published years ago on the Binary Mechanic website. And yesterday I showed the hadron bit cycle, which has 42 locations. So that's 2 to the 42 spot cube hadron states are defined. So that's the summary then of my essentials in crafting a cosmological model. Things to look out for that should be excluded and things that hopefully you might consider including. Thanks for your attention.